Hello, everyone. We're going to be doing the very last section here in Chapter 7 today. If you have your student journal, you can join along. We're on 236 here in the student journal. And we're going to be talking about factoring these special products. Okay, so factoring special products. And a lot of times, I think sometimes people try and apply the rules that we're doing in 7.7 and they try and use it on different trinomials and other things like that. They try to factor a lot of stuff. The thing to really keep in mind with this section is I'm going to show you a couple little rules and little tricks to make some types of factoring easier. But the thing to keep in mind is it really only works on the two special products I'm going to show you. So this is just like 7.3 where you have these different types of binomials and you can FOIL them out just like normal, but there's a couple shortcuts and tricks to kind of patterns that these special types of binomials and trinomials follow. Okay, so first example, we've got our difference of two squares. And notice, again, this is just what we did in 7.3 because we're going the opposite direction. Instead of like FOILing and multiplying them out, we're factoring them. Okay, so what this one is telling us is if we have a squared minus b squared, we have two perfect squares, we're subtracting one of them. That gets factored as a plus b and a minus b. So the square roots of these perfect squares. Okay, so we have this example right here. So x squared minus 9, that's going to get factored as x plus 3 times x minus 3. X and 3 are the square roots of x squared and 9. Okay, so I want to show you something. I've got this x squared minus 4. Okay, if I tell you, okay, factor that, there's two ways that you can think of this. You could factor this out normally. You could say, you know what, I'm going to make this into a normal trinomial that I'm used to. Okay, x squared. I don't have just an x term. I don't have a b value. So I'm just going to say this is 0x, right? And then minus 4. So I would do the same thing that I've done before. I can do the little x and say, well, I want it to add up to 0 and multiply to negative 4. We're really just using the same process we've seen before. Okay, I know since it's multiplying to a negative, I want a positive and a negative here as my two factors. So in order for it to add up to 0, I'm going to need positive 2 and negative 2. Okay, so this is going to factor as x plus 2 and x minus 2. But a little bit easier of a way to think about this is as this difference of two perfect squares. I've got x squared minus 4. I know that both of those numbers are perfect squares. And really, if I ever give you a binomial like this and say, okay, factor it, either there's a common factor, a GCF that you can take out, or it's going to be this difference of perfect squares. So I know that the square root of x squared is just x. And I know the square root of 4 is 2. So to follow this pattern, I'm going to say, okay, well, that's just going to factor out to x plus 2 and x minus 2. I get the exact same answer as if I had factored it out the old way, right? And you can only do this if you have two perfect squares and you're subtracting one of them, right? So between these two problems, it's probably about the same difficulty level to factor one way or the other, but a lot of the problems you're going to see, especially in your homework today, where you have just special products, you might see something like 16x squared minus 49. And you could put in that middle term of 0x and do all this stuff where you would have to do slide and divide because you have an a value, all that stuff. But really, what you want to think about is these are two perfect squares that you're subtracting. So you want to think of the square root of each of these. So 16x squared, The square root of that is just 4x. Okay, square root of 49 is just 7. So we can just go through and say, well, I know this is going to be 4x plus 7 and 4x minus 7. That's where this trick kind of comes in handy. It saves you a little bit of time with something that would be kind of a complicated problem to do the other way. Alrighty, let's look at perfect square trinomials. I think for a lot of us, identifying perfect square trinomials is a little harder than just difference of two perfect squares, right? Sometimes it might be hard to identify what is in this special pattern versus what is just, a normal trinomial. I think the key thing here, one, as you're doing the 7-7 homework, everything in here is is one of these perfect square trinomials or the difference of two squares. But as you're just going through normal factoring, you're trying to decide if you can use this, it's got to follow this kind of rule here, this a squared minus 2ab plus b squared. So over here, we can see that really in numbers. We can see x squared and 9. Those are both perfect squares. And that middle term, okay, my square root of x squared is x. My square root of 9 is 3. So my middle term should be this x times 3 times 2, which is, 6x. So this is that perfect square trinomial. That's the pattern it follows. And the second type, it's exactly the same, except we've got a negative sign here. That's the only difference between these two, is sometimes the middle term is positive, sometimes that middle term is negative. Okay, but either way, the way we factor this out, it's pretty simple, is we say, okay, well then this is just the square root of this first term and the square root of the last term. If it's positive, we're going to add them together. We could call it a plus b times a plus b, but the simplified version of that is just a plus b all squared. Okay, just like over here. We know that the square root of x squared and the square root of 9, we've got x and 3, so we'll call that x plus 3 times x plus 3, which is the same thing as x plus 3 squared. This is another one of those where if this is confusing, you could just factor this out like normal. Let's look at this second one over here. Okay, this x squared minus 6x plus 9. Okay, x squared minus 6x plus 9. I could think, okay, I need numbers that multiply to 9 but add to negative 6. I know, okay, it's multiplying to a positive, adding to a negative, so I need two negative numbers, so that's going to get me 3 and 3, negative 3 and negative 3. So I'm going to say, okay, well, that's just x minus 3 times x minus 3, which we simplify. It's the exact same sign in the middle, so I'm just going to call that x minus 3 all squared. Alrighty. And again, the reason this is a little bit helpful, I'm going to come up with another problem here. If I give you something like 36x squared plus 84x plus 49, that would be kind of a monster to try and factor out the way that we've done with this a times c, the slide and divide stuff. Okay, you'd end up having to multiply the 36 by 49. Okay, I'm just doing some math here. 36 times 49. It gets you like 1,764. So finding all the factors of that really wouldn't be fun. So instead, we can identify that it follows this pattern. We see that the first term and the last term are both perfect squares. So, okay, this 36x squared, well, I know that the square root of that is just 6x. The square root of 49 is 7. If I want to make sure it follows the pattern, I can think, okay, well then if it is this perfect square trinomial, this middle term would be 6x times 7 times 2. Okay, 6 times 7 is 42, and then times 2 would be 84x. So this is a perfect square trinomial. You don't really have to do this step, especially in the homework where you know everything. All the trinomials are going to be perfect square trinomials. Okay, so you can use that pattern and say, okay, well, I know this is just going to be a plus b squared. I'm going to have a, which is the square root of 36x squared, plus, because it's a plus sign right here, square root of 49, which is 7, times 6x plus 7. Oh, I don't know why that happened. Okay, plus 7. And I know that can simplify just down to 6x plus 7 all squared. Alrighty, so really quick, let's just look at a couple problems. I want to look over here where we're just going to go ahead and solve some. Okay, because I think we've got a little bit of solving in our homework, so I just want to make sure we feel confident about that. When you are solving, just like all the other solving that we've done in this chapter, if you're solving an equation, what you really need to think about doing is factoring first and then setting each factor equal to 0. So if I give you something, let's look at 20. If I give you something like this 9y squared is equal to 49, that should set off an alarm bell when it's not equal to 0 right away. You want it to be equal to 0. You want to say, let's move that 49. Okay, I'm going to subtract it here from both sides. We get 9y squared minus 49 is equal to 0. And then now we can factor. We know this is a perfect, or difference of two perfect squares, so I know, okay, well, the square root of 9y squared, that's 3y. Square root of 49, that's 7. And so the way difference of two perfect squares worked is we're going to do 3y plus 7, 3y minus 7. They've got to be opposite signs there. Okay, all equal to 0. And just like all the other factoring, we want to set each factor equal to 0. Okay, so we're going to subtract 7 and get 3y is equal to negative 7 and divide 3 and get y is equal to negative 7 thirds. Okay, same thing over here. We're going to add 7 first. Always got to add and subtract before we divide. Not equal to 0 anymore. It's equal to 7. Okay, divide by 3. And I get y is equal to 7 thirds. So y is equal to negative 7 thirds and positive 7 thirds. Okay, same thing over here. I've got a perfect square trinomial. Okay, I'm going to use my knowledge. I'm going to say, okay, well, c squared is a perfect square. The square root of that is c. The square root of 49 is 7. So when I have the perfect square trinomial, I know I'm going to have the same sign both times. It's going to be c plus 7 and c plus 7. Okay, it's a plus because this is a plus. Over here where you have a minus, it would be minus. Okay, is equal to 0. We can change it to c plus 7 all squared. When you're solving, I'm not really too worried about how you write it out because either way, you can set two c plus 7's equal to 0. And we're going to end up with c is equal to negative 7 for each of them. You don't really have to include both in your answer, but you may want to write a little note that negative 7 is a repeated root. Way back when we first started solving these, repeated root, that's when you have 2 copies of one answer, or 3 or 4 instead of just 1. Right? Make sure you go ahead. We've got the 7.6 assignments, both of those, and then the 7.7. That's really all you have to turn in by Friday to make sure that nothing is late credit. And then I'll give you that practice test very soon to make sure that you can get ready for our Chapter 7 test coming up next week. Please send me any emails if you have any questions, and I'll see you guys soon.